Your heart stops. 30 seconds later, your brain runs out of oxygen, neurons stop firing, you lose consciousness, and then what? Most people say you're gone. But physics says something completely different. According to the laws of thermodynamics, quantum mechanics, and information theory, you can't actually die, not in the way you think. Let me tell you what happens in your final moments from the perspective of physics. Your heart stops, blood stops flowing. Within seconds, your brain cells start running out of oxygen. They can't produce ATP, the energy currency of life. Without ATP, ion pumps fail. Sodium floods into neurons. Potassium floods out. The electrical gradients that enable neural firing collapse. Your consciousness doesn't shut off like a light switch. It fades gradually over about 20 to 40 seconds. First, you lose the ability to form new thoughts. The prefrontal cortex shuts down. Then you lose awareness of your surroundings. The sensory processing regions go quiet. Then you lose sense of self. The default mode network, the regions that maintain your sense of I, stops functioning. Finally, there's nothing, no experience, no awareness, no you. This takes less than a minute, from cardiac arrest to complete loss of consciousness, about 40 seconds. But here's what's strange. During those 40 seconds, nothing leaves your body. No soul departs. No essence escapes. Every atom that was part of you is still there. Every molecule, every bit of matter and energy. So what died? What actually ended? Richard Feynman thought about this question deeply, especially after losing people he loved, his first wife Arlene, his mother. Eventually he faced his own death, and his answer was precise, physical, unsentimental. What dies is not matter or energy. What dies is organization, structure, the specific pattern that made you you. Let me explain what that means. In thermodynamics, there's a concept called a dissipative structure. It's a system that maintains order by constantly consuming energy and increasing entropy in its surroundings. A flame is a dissipative structure. It maintains its form, the dancing shape, the glowing plasma, by consuming fuel and releasing heat. The flame itself is ordered, but it creates disorder around it. Total entropy increases. You are a dissipative structure, a much more complex one. You maintain your organization, your body temperature, your cellular structures, your neural patterns by consuming energy from food and oxygen. You're constantly fighting the second law of thermodynamics, which says that entropy always increases. Your body wants to reach thermodynamic equilibrium with your environment, the same temperature, the same chemical concentrations, maximum entropy, minimum order. But while you're alive, you prevent this. You maintain a temperature of 37 degrees Celsius even when the environment is 20 degrees. You maintain concentration gradients across cell membranes even though diffusion wants to equalize them. You maintain complex molecular structures even though they want to break down. This requires energy, about 2,000 calories per day for an average adult. That energy comes from breaking down food molecules, carbohydrates, fats, proteins, and releasing the energy stored in their chemical bonds. Where did that energy come from originally? Sunlight. Plants captured it through photosynthesis. You ate the plants or animals that ate the plants. You extracted the solar energy. So you are a temporary eddy in the flow of energy from the sun to the cold depths of space, a local decrease in entropy powered by a larger increase in entropy elsewhere. And when you die, this energy flow stops. You can no longer extract energy from food. You can no longer fight entropy. The second law takes over. Your body temperature drops to match the environment. Chemical gradients equalize. Proteins denature. Cell membranes rupture. Bacteria begin decomposition. Within hours, you're no longer an organized system. You're becoming a collection of molecules at thermodynamic equilibrium. The dissipative structure collapses. The pattern dissolves. But here's where it gets philosophically interesting. What about the information? You weren't just any collection of molecules. You were a specific arrangement, a specific pattern, and that pattern encoded information. The connections between your neurons encoded your memories. The sequence of base pairs in your DNA encoded instructions for building you. The configuration of molecules in your cells encoded your current metabolic state. All of this is information. And in physics, information is deeply connected to entropy. In the 1940s, Claude Shannon developed information theory. He defined information mathematically as the reduction of uncertainty. The more uncertain something is, the more information it takes to specify it. In the 1960s, physicists realized that Shannon's information is connected to thermodynamic entropy. Entropy is not just disorder, it's missing information. When entropy increases, you lose information about the system. A perfect crystal at absolute zero has zero entropy. You know exactly where every atom is, maximum information. As the temperature increases, atoms vibrate randomly. Entropy increases, you lose information about their exact positions. When you die, the information that was you starts to degrade. The patterns in your brain begin to dissolve as neurons die and decompose. The structures in your cells break down. The information becomes scrambled, mixed with everything else. But here's the key insight from physics. Information cannot be destroyed. This is a fundamental principle of quantum mechanics related to the unitarity of quantum evolution. When you burn a book, the information in the book doesn't disappear. It's encoded in the smoke particles, the photons that radiated away, the heat that dissipated. It's scrambled beyond any practical recovery, but it's not destroyed. Same with you. When you die, the information that encoded you doesn't vanish. It disperses. It becomes part of the environment. It spreads out across countless atoms and molecules. In principle, with perfect knowledge and unlimited computational power, that information could be recovered. Your memories could be reconstructed. Your personality could be restored. This is purely theoretical. In practice, it's impossible. The information spreads so widely and becomes so thoroughly mixed that recovering it would require knowing the quantum state of vast portions of the universe. But fundamentally, physically, the information persists. Let's go deeper. Let's talk about quantum mechanics. At the quantum level, every particle that was ever part of you, every electron, every quark, remains forever connected to other particles through quantum entanglement. Entanglement is a phenomenon where particles that have interacted remain correlated even after they separate. Measure one particle and you instantly know something about the other. No matter how far apart they are, Einstein called this spooky action at a distance and thought it proved quantum mechanics was incomplete, but experiments have confirmed it's real. Particles can be entangled across any distance. Now every atom in your body has interacted with countless other atoms. Every photon your eyes absorbed came from somewhere, the sun, a light bulb, another person's body heat. Those interactions create entanglements. When you die, those entanglements don't disappear. The particles that were part of you remain quantum mechanically correlated with particles throughout the universe. What does this mean? It means that information about you is encoded not just in the particles that were directly part of your body, but in the vast web of quantum correlations extending outward from every interaction you ever had. This is related to the holographic principle in physics, the idea that all the information in a volume of space can be encoded on its boundary. Information is non-local. It's spread out. It's woven into the structure of space-time itself. So when you die, you don't disappear from the universe's quantum state. You become part of it. Your information is encoded in the correlations, the entanglements, the quantum coherences that permeate reality. Again, this doesn't mean you survive in any meaningful sense. Your consciousness ends, your experience stops, but the information that was you scrambled, dispersed, quantum mechanically encoded, remains part of the universe forever. Now let's talk about why death is irreversible. If the laws of physics are time symmetric, if they work the same forward and backward, why can't you undie? Why can't all those scattered molecules spontaneously reassemble into you? The answer is entropy. The second law of thermodynamics: when you die, your body goes from a low entropy state, highly organized, to a high entropy state, disorganized. This is overwhelmingly probable. There are vastly more ways to be disorganized than organized. The reverse, going from high entropy back to low entropy, is not impossible. It doesn't violate any fundamental law, but it's so staggeringly improbable that it effectively never happens. How improbable? Let's estimate. Your body contains about 7 times 10 to the 27th atoms. To spontaneously reassemble, you would require those atoms, along with countless others in the environment, to arrange themselves in exactly the right configuration. The number of possible arrangements is astronomical. If you tried one arrangement per Planck time, the shortest meaningful time interval, about 10 to the negative 44 seconds, it would take far longer than the age of the universe, billions upon billions of times longer, to try even a tiny fraction of possibilities. The probability of randomly hitting the exact configuration that is you is essentially zero. Not zero exactly, but so close that the distinction doesn't matter. This is why death is irreversible. Not because of a fundamental law that forbids reversal, but because the universe is so vast, the possibilities so numerous, that reversal is statistically impossible. The arrow of time, the fact that we age, that things decay, that death is permanent, emerges from entropy, from statistics, from the overwhelming likelihood that disorder will increase rather than decrease. June 16, 1945. Richard Feynman sat beside his wife Arlene as she died. She had tuberculosis. She was 25 years old. They'd been married for 2 years, though they'd known each other since high school. He loved her deeply. He watched as her breathing slowed, became irregular, stopped. The nurses noted the time of death. Feynman looked at the clock on the wall. Then he noticed something that would bother him for the rest of his life. The clock had stopped at exactly the time Arlene died. For a moment he felt a chill, a sense of the supernatural, as if the universe had marked her death with a sign. Then his scientific mind took over. He examined the clock. It was a cheap electric clock, the kind that needs to be upright to work properly. The nurse must have moved it when recording the time, laying it flat on the table. The mechanism jammed. Pure coincidence. But the emotional impact remained. For years afterward, he thought about that moment, the feeling of wanting there to be meaning, wanting there to be something more than mere physical processes. And his conclusion, there wasn't. Death is physical, the stopping of a heart, the cessation of brain activity, the collapse of a dissipative structure. Nothing supernatural, nothing mystical, just atoms obeying physical laws. But that didn't make it meaningless. The atoms that were Arlene didn't disappear. They returned to the biosphere. The energy that animated her dispersed into the environment. The information that encoded her, scrambled but not destroyed, remained part of the universe. And most importantly, she had existed. She had been a conscious being. She had experienced love, thought, feeling. That couldn't be undone. It was part of history, part of the structure of space-time. In the block universe view of relativity, her life still exists, just at a different coordinate in time. This was Feynman's consolation. Not that she survived somehow, but that she had been. And being, even temporarily, was worth something. Let me tell you something that might sound contradictory. You are simultaneously temporary and eternal. Your body is temporary. The specific collection of atoms that makes up your body right now will disperse when you die. They'll become part of soil, air, water, other organisms. But the pattern, the information structure that is you, that's more complicated. Think of a wave on the ocean. The wave is a pattern of water molecules, but the molecules themselves aren't moving with the wave. They're just oscillating up and down as the wave passes through. The wave is real. You can surf on it. It carries energy. It has effects. But it's not made of any particular water molecules. It's a pattern that moves through the water. You're similar. The atoms in your body are constantly being replaced. You breathe in oxygen, breathe out carbon dioxide. You eat food, excrete waste. You shed skin cells. Over about 7 years, most of the atoms in your body are replaced. So you're not your atoms. You're the pattern, the organization, the information structure. And patterns can persist in strange ways. The information in your DNA gets passed on to your children, a modified version of you. A pattern related to your pattern continues. The information in your brain affects the world. Your actions create ripples. You teach someone something, and that information lives in their brain. You write something, and the pattern of ideas persists in the text. You create something, and it remains after you're gone. In this sense, parts of you are immortal, not your consciousness that ends, but the information patterns that were shaped by you. Those propagate forward in time, influencing the future in ways large and small. Feynman understood this. He spent his life teaching. His lectures were recorded, his books were published, his ways of thinking, his approaches to problems, his particular style of understanding physics, these patterns of information spread through the physics community and persist today. He didn't do this for immortality. He did it because it was interesting, useful, beautiful, but the effect is the same. Parts of him, information patterns, continue. Now let me tell you about something really strange, a physics interpretation that suggests you might be immortal in a weird way. In quantum mechanics, there's something called the many worlds interpretation. It says that every quantum measurement causes the universe to split into multiple branches, one for each possible outcome. Schrodinger's cat is both alive and dead until you open the box. But in many worlds, when you open the box, the universe splits. In one branch, the cat is alive. In another branch, the cat is dead. Both branches are real. Now apply this to death. Every moment there are quantum events in your body that could lead to your death or your continued survival. A cosmic ray hitting a critical neuron, a quantum fluctuation in a key molecule. In most branches you die at some point. But in some branches, increasingly improbable branches, you keep surviving. Every quantum coin flip that could kill you comes up survive in some branch. This leads to a strange idea called quantum immortality. In your subjective experience, you only exist in branches where you're alive. You can't experience branches where you're dead. So from your perspective, you keep surviving, no matter how improbable. In most branches, everyone else sees you die. But there's always some branch where you survive another day, another year, another century. This is highly speculative. Most physicists don't take quantum immortality seriously. It requires accepting many worlds, which is controversial. And it leads to bizarre conclusions, like that you should expect to find yourself as an improbably old person having survived countless near-death experiences. But Feynman found it interesting as a thought experiment. It shows how strange quantum mechanics is. It suggests that the question, do I survive death, might not have a simple yes or no answer. Maybe in some sense, in some branches of reality, everyone is immortal from their own perspective. He didn't believe it literally, but he appreciated how it revealed the weirdness of quantum mechanics and the difficulty of thinking clearly about consciousness and identity. So what actually survives death? Let me summarize what physics tells us. Your atoms survive. They don't disappear, they get recycled. The carbon in your body becomes carbon dioxide, gets absorbed by plants, becomes part of other organisms. Your atoms are immortal, though they lose their identity as your atoms. Your energy survives, energy is conserved. The energy that powered your metabolism, your thoughts, your movements, it doesn't vanish. It dissipates as heat. It radiates away. It becomes part of the thermal energy of the environment, but it still exists. Your information survives, in a sense, not in a recoverable form, but the quantum state of the universe includes correlations that encode what you were. The information is scrambled, dispersed, effectively lost, but not fundamentally destroyed. Your influence survives. Every action you took changed the world in some small way. Those changes propagate forward. The butterfly effect means even tiny changes can have large consequences over time. You've altered the trajectory of the future simply by existing. Your patterns survive in others. Ideas you taught, behaviors you modeled, genes you passed on, memes in the original sense, units of cultural information, these patterns continue after you're gone. What doesn't survive? Your consciousness, the subjective experience of being you. When your brain stops functioning, that experience ends. There's no evidence it continues in any form. Feynman was clear about this. When I die, I die. The atoms go on, the energy goes on, but I, the experiencing, conscious me, that stops. And that's okay. I got to exist for a while. That's remarkable enough. Knowing that death is just the dissolution of a pattern, does that make it less frightening or more? For Feynman, it made it less frightening because it removed the mystery. Death isn't some unknowable transition to another realm. It's a physical process, understandable, predictable, natural. The atoms in my body came from stars that exploded billions of years ago. They were cycling through Earth's biosphere for eons before becoming me. They'll cycle through for eons after I'm gone. I'm just a temporary arrangement, a brief moment when these atoms happen to be organized into a conscious being. That's not sad, that's beautiful. He found meaning not in eternal life, but in temporary existence. You get to be conscious, to think, to understand, to love for a brief time, and then you return to the universe that made you. This perspective doesn't require religious faith. It doesn't require believing in souls or afterlives. It's just physics. But it's physics that reveals something profound about existence. You are the universe looking at itself. You are matter organized in such a way that it knows it exists. For a brief moment, a small portion of the cosmos becomes aware, experiences, understands. And when you die, that awareness ends. But the matter and energy don't. They continue. They become part of other things, maybe someday part of other conscious beings. In this sense, death is transformation, not ending. You don't cease to exist. You cease to be you. The pattern dissolves, but the substrate, the atoms, the energy, the quantum information that persists forever. February 1988. Richard Feynman was dying of cancer. He knew it. The doctors knew it. He was 69 years old. He spent his last days working, doing physics, teaching, thinking, right up until the end. A friend visited him in the hospital, asked how he was feeling. Feynman said, "I'm preparing for death. I'm organizing my thoughts, making sure I understand what I understand and admit what I don't understand." The friend asked, "Are you afraid?" Feynman thought for a moment. "No, I'm curious. Death is something I haven't experienced yet. It'll be interesting to see what it's like in those final moments. And then, of course, I won't see anything because I'll be gone." He paused. "I'm sad about what I'll miss, the science that hasn't been done yet, the questions that won't be answered in my lifetime. But that's always true. You always die before everything interesting happens. That's just how it is." On February 15, 1988, he died. His last recorded words were, "I'd hate to die twice, it's so boring." True to character, facing death with clarity and humor. No denial, no false hope, just acceptance of the physical reality. And the atoms that made Richard Feynman, they dispersed into the air, into the earth. They're still out there, part of the ongoing cycle of matter and energy. The pattern that was Feynman, his unique way of thinking, his insights, his personality, that dissolved. But the information he created, the ideas he taught, the ways of understanding he developed, those persist in books, in minds, in the ongoing practice of physics. He's gone. But he's also still here, in a sense, not as a conscious being, but as information patterns, as influence on the future, as atom redistributed through the biosphere. Death, explained by physics. What does it actually tell us? Death is the end of a dissipative structure, the collapse of organization, the increase of entropy, the dissolution of a pattern. It's not the end of matter or energy. Those are conserved. They continue, transformed into other forms. It's not the complete end of information. That information disperses, quantum mechanically encoded in correlations throughout the universe, effectively lost, but not fundamentally destroyed. It's the end of consciousness, the end of experience, the end of you as a subjective being. And physics tells us this is irreversible, not because of a fundamental law that forbids resurrection, but because the statistical improbability of spontaneously reassembling is so extreme that it's effectively impossible. You are temporary, a brief arrangement of atoms that knows it exists, and then the arrangement dissolves and the atoms continue without you. Feynman found this beautiful, not sad, I am part of the universe, I came from it, I'll return to it. For a brief time, I get to be conscious. That's enough. That's more than enough. That's everything. Physics doesn't promise immortality. It promises transformation. You don't survive death, but the matter and energy that made you do, they continue forever. Part of the ongoing dance of the cosmos and the information that was you, your ideas, your actions, your influence that propagates forward, shaping the future in ways you'll never see. Death isn't the end of everything, just the end of you. And from the perspective of physics, that's exactly as it should be. Atoms and energy are immortal. Patterns are temporary, and you are a pattern. That's what physics says. That's what Feynman understood. And once you understand it too, death becomes less mysterious, less frightening, not because it's not real, but because you see it clearly as it is, a physical process, the universe recycling itself. You came from stars. You'll return to the cosmos. And for this brief moment in between, you get to think, feel, understand, and wonder. That's death, explained by physics.